Hello, everybody. Welcome to another webinar organized by 99X. So today we're going to dive into the world of cybersecurity. In an interconnected world where cyber attacks are becoming more and more sophisticated, investing in cybersecurity cannot be an afterthought. So in this webinar, we're going to talk about the nature of secure by design philosophy and how secure by design can be used to proactively secure information systems. So let's dive in. So I'm Kanish Kabekon. I'm going to be the speaker for today's webinar series. I have actually more than 4 years of experience working in the cybersecurity industry. And also I have experience in conducting compliance audits and also ISO information security management systems and business continuity management systems audits as well. And I have conducting vulnerability assessment and penetration testing in mobile applications, APIs and web application experience as well. And currently now I'm working at 99X, and the project I'm attached in Bulimappa. And also I am a co-founder and co-host in Apprentice Podcast, where we talk about art, technology, and cybersecurity as well. So let's dive into today's agenda. So today we're going to talk about back to the basics, going to the back to the basics, where we'll talk about 3 pillars of cybersecurity. Actually, it's one of my favorite things to start when conducting a presentation related to cybersecurity, because it will give you an idea about cybersecurity, and if there are any issues related to cybersecurity, you can actually map those things into the basics. So we will talk about basics, and we'll talk about the significance of secure by design, how important secure by design, and we will go into insights in secure software development as well. And we will talk about what can we do to identify and prevent risks. And also we will talk about some technical aspects as well, which is related to secure design patterns. And we will talk about 3 secure design patterns as well. Yep, so let's dive into this session. So yeah, as you can see on the screen, there's a triangle, saying confidentiality, integrity, and availability. Of course, those are the 3 pillars of cybersecurity. So I'll start with a simple example where we going to an ATM to withdraw money from our bank accounts. So when we talk about bank confidentiality, it's basically the data should not be accessed or read without authorization. So if we talk about the example, let's say we are going to look at our bank account balance or our transaction history. So there's going to be some personal identifiable information as well. So what does confidentiality means? It means the data should not be accessed or read without prior authorization. So actually what it does, it ensures that only authorized parties have access to our confidential information. And when it comes to integrity, we can actually think about integrity. Let's say when we are going to check our bank account balance, let's say our bank account balance has been tampered with. When we are looking at the ATM display, we see there's no money in my bank account. So what happened to my money? So that is kind of a integrity violation. So we can actually take that example to tackle integrity. So what does integrity means? Integrity means is data should not be modified or compromised in any way. So it actually assumes that data remains in an intended state and can only be edited by authorized parties. So let's say we are going to change our contact details. It might be our contact number or email address where we're going to log into the banking system. So that kind of information can only be changed by ourselves, only the ones who have access to the bank account or that particular system. So if those information are tampered with, then there's going to be an integrity violation, and that is will lead to cyber incident. So then again, we have availability. So availability is as in sense, let's say we're going to withdraw money from the ATM, and at that time the ATM is not working. So we won't be able to access our bank account and withdraw money. It might be emergency situation where we won't be able to withdraw our money. So at that time, that particular service won't available to the end user, and it is also another violation of availability. So in availability, as in sense, it means data should be accessible upon legitimate request. So it ensures that authorized parties have unimpeded access to data when required. So those three are the three pillars of cybersecurity. So that is the simple way of explaining what is integrity, what is confidentiality, and what is availability, and how it can impact to a system or an application if those three pillars are violated. So let's go into our next slide. So so we, as I mentioned, we're going to talk about the significance of secure by design. So secure by design, it is more than just a concept. It's a philosophy actually that underlines the importance of integrating security measures into the very foundation of systems, processes, and products from the outset. So it's actually a proactive approach that acknowledges the dynamic and evolving nature of cybersecurity threats. So as a philosophy, secure by design, it actually advocates for making security an inherent and integral part of every stage of development, rather than treating it as an add-on or an afterthought. So actually this approach, it recognizes that building secure systems requires thoughtful planning, consideration, and a mindset that prioritizes security from the beginning. And in essence, actually, secure by design is a guiding principle that influences decision-making and actions throughout the entire life cycle of system or product. So actually, secure by design, it emphasizes the need for a holistic and preemptive security strategy. Also, it aims to prevent vulnerabilities and mitigate risk before they become issues. So we'll dive into the significance of secure by design. I have prepared a slide where I have gathered some stats from one of the surveys conducted by Gartner. So as you can see on the screen, on your right side, the illustration emphasizes open source software supply chain attacks. As you can see on the screen, year over year, it has been increased tripled. And you can see compared to 2020, compared to 2019, it has been increased by 430%. And also when it comes to 2022, it has been increased by 742%. So those open source software supply chain attacks, those have been increasing year after year. And if we predict it for 2023, it's going to be increasing moreover, and there's not going down. So also, if we look at the left down bottom of the slide there, you can see the top prediction for 2023 and beyond. It says ransomware threat. It has been 30% of nations pass legislation on ransomware. And also it says weaponize of OT. So it will result in human casualties by 2025. And also you can see third party 60% of third party will use cybersecurity risk as a primary determinant for business transactions. So these surveys and researches have been conducted to identify the importance of cybersecurity and the increasement of cybersecurity threat landscape. So as you can see, year after year, that threat landscape is increasing, and we need to be proactively join and integrate cybersecurity into our development life cycles. We'll go to our next slide, where we're going to talk about the secure software development life cycle. As you can see on the screen, you can see that there are a couple of our usual software development life cycle. So it says just requirements, design, development, testing, and deployment phases, usual ones, and how this is going to be different from the normal software development life cycle, and how it's going to be differentiated between secure software development life cycle. So what we can see is in the requirement phase, we'll talk about like from the inception of a software development project, we can actually incorporate security consideration into the project planning and clearly define and document security requirements. In that phase, we can actually identify what sort of security requirements are there. And we can actually conduct a risk assessment and identify what are the probable risks are there. And we can take mitigations at the inception of the project. So and the next, we can see the design principle. So design phase, we can see that we are incorporating threat modeling, and we can actually do a design review, secure design review, where we can identify what are the interfaces and what are the inputs and outputs are there, and how like implementing this kind of design will increase the threat landscape, whether it is going to increase the risk that we have. So if we are incorporating threat modeling and design reviews, we can actually identify those risks and design the software or the application in a secure way. And also, when we come to the development stage of it, we can actually apply secure coding practices to mitigate vulnerabilities, where we can use secure coding standards, and also we can use conduct code reviews as well. Basically, it's going to be a focus on security as well, so we can conduct code reviews. And we can also use automated security testing tools to the development environment as well. So let's say we can actually bring in a static application vulnerability scanner to identify vulnerabilities within the code level. So from the development stage, then it will identify those vulnerabilities, and we can mitigate them right away. And when it comes to the testing phase, we can perform comprehensive security testing throughout the testing phase, and we can actually conduct dynamic analysis or as well, or security focused testing to identify and address vulnerabilities. So after that, we have our final stage, the deployment stage, where we're going to conduct a vulnerability assessment or a penetrate testing after the software or application has been deployed to the live environment. And also, one thing we need to keep in mind that we have to provide training and awareness to the IT professionals who is going to be involved within this secure software development life cycle. So we can actually increase their awareness when it comes to conducting, let's say, a secure code review, or identify vulnerabilities, looking at the static analysis report, whether those are false positives or false negatives. We can actually provide that kind of training to any kind of IT professionals who have been involved in this development life cycle. Also, we can teach them how to conduct a risk assessment, something like that. So, like by following a secure SDLC, the organizations like aim to produce a software that is resilient to security threats and meets high standards of confidentiality, integrity, and availability. So it's going to be a holistic and proactive approach. that acknowledges that security is not a one-time event, but an ongoing process throughout the software development life cycle. So that way we can ensure software security has been enforced and implemented from the inception of software project to the deployment of a software project. And also we can actually continuously monitor our security vulnerabilities and threats and apply mitigations continuously. So in the next slide, we're going to talk about DevOps and DevSecOps. Basically, DevOps has been within our software development practice over a decade now. So now the best thing is going to be, next big thing is going to be DevSecOps, bringing a culture of secure, a focused culture into the DevOps culture. So we'll differentiate between DevOps versus DevSecOps in our next slides. Yep. So as you can see on the screen, DevOps actually focuses on collaboration between development and operations teams to streamline development and delivery process. Actually, on the other hand, DevSecOps extends this by integrating security practices throughout the entire DevSecOps life cycle. Actually, DevSecOps is an extension of DevOps. So basically, we are integrating security into each and every stage of DevOps. So that's where it's going to be a DevSecOps culture. So it actually emphasizes the importance of security at every stage. So you can think of it as embedding security into DevOps culture, while DevOps aims at fast and efficient delivery. DevSecOps ensure that security is not compromised in the pursuit of speed. So, actually, in terms of connecting them to a secure software development lifecycle, DevSecOps is essentially an implementation of secure development lifecycle within a DevOps framework. So, yeah, it's about weaving security seamlessly into every phase of the development lifecycle, rather than treating it as a separate, isolated step. So, yeah, we'll be diving into a couple of principles, which is we're going to compare them with the DevOps and the DevSecOps cultures. What sort of principles are there in order for us to move from a DevOps culture into a DevSecOps culture? So, as you can see on the screen, the number one is going to start with the shift left security. Actually, DevSecOps encourage a shift left approach, meaning that security considerations are moved earlier in this development life cycle. And we can actually, as an example, we can say security testing and checks are integrated into the development process from the very beginning, catching vulnerabilities at an early stage when they are easier and less expensive to address. And here comes automation. We can actually use automated security testing tools and get them integrated into the CI/CD pipeline to perform static analysis and dynamic analysis and any other security checks automatically. So that way, automated scans identify security vulnerabilities and any kind of compliance issues are there as part of the regular build and deployment process. So we can actually configure our CI/CD pipeline to perform any kind of security testing, and if there are any security vulnerabilities, which is if compromise, the impact is going to be critical. So we can actually set our environment to fail the build. Then we can address those critical vulnerabilities and mitigate them right away before deploying them into a staging environment. And also, we have continuous monitoring. Of course, continuous monitoring of applications and infrastructure actually is a key aspect of DevSecOps. This involves real-time monitoring of security metrics, logs, and events to detect and respond to security threats promptly. And yeah, we have collaboration and communication because DevSecOps fosters collaboration and communication between development, security, and operations teams. So that way, security teams will be working closely with developers to provide guidance, share best practices, and ensure that security requirements are met in each and every phase of DevSecOps. And also, we can conduct threat modeling as part of the DevSecOps culture. It includes the threat modeling as part of the design phase to identify potential security threats and vulnerabilities early in the development process. So as I mentioned, this is like an extension version of the secure development lifecycle. So this will help in making informed decisions about security controls and mitigation. And also, we have incident response. We actually ensure, if you're going forward with DevSecOps culture, that incident response is an integral part of the development lifecycle. And also it plans, and there are procedures for handling security incidents when the application is developed and tested and integrated into the overall development and deployment process. Also, we have compliance and governance. So DevSecOps incorporates mechanisms for ensuring compliance with regulatory requirements and industry standards, because we can actually set automated checks implemented to validate that application and infrastructure adhere to security policies and compliance standards. So everything will be covered. Those are the principles where comes within DevSecOps. So by incorporating these principles, DevSecOps helps create a more resilient and secure development life cycle. It will reduce the risk of security breaches and ensure that security is not treated as an afterthought, but as an integral part of the development process. Yep. So we'll go to our next slide, where we will be going to talk about secure design patterns. We will talk about 3 secure design patterns. So these will be important when it comes to integrating security into our architecture. It can be into our architecture or applications, or into our physical environments as well. So first, we have defense in depth. So defensive depth is strategy is like having multiple layers of defense, where even if one layer is breached, then there's another additional layer to prevent further compromise. So it's not just about one phase, it's about consistently applying layers of defense from coding to deployment. If I take an example to explain defense in depth, we can take a cloud-based development environment. An organization might use a combination of network firewalls, intrusion detection systems, regular security audits, and automated vulnerability scanning tools at different stages of development. And this multi-layered approach ensures that even if one layer is breached, there are additional barriers to prevent further exploitation. And next, we have least privilege. So least privilege principles, actually, it follows the idea of giving individuals or systems the minimum level of access or permissions they need to perform their duties. So actually, it limits the potential damage in case of a security breach. If I take another example about least privilege, we can actually consider a microservice architecture. So each microservice is granted the minimum permissions required to perform its specific function and no more. So developers and operation teams adhere to the principle of least privilege by configuring access controls, ensuring that each component has only the necessary permissions to function. So this will reduce the potential impact of a compromised microservice. And if we talk about our next design pattern, is going to be deny by default. So this is a proactive approach, obviously, where everything is denied access by default and only specific necessary permissions are granted. So it helps in minimizing the attack surface. So by defaulting to deny access and carefully granting permissions, it's about anticipating potential security threats and taking measures to block them before they become issues. So if I take another example about deny by default pattern, we can actually take a containerized application deployment. The default settings for network policies might be to deny all incoming and outgoing traffic. So the access is then explicitly granted only to the required services. So this approach, actually, it minimizes the attack surface by starting from a position of strict denial, ensuring that only authorized communication is allowed. So these are the things that we want to talk about today. So we talked about the significance of secure by design, and we talked about secure development life cycle, and also we talk about the difference between DevOps and DevSecOps, and how this is going to be applicable in secure development life cycle. So we talked about DevSecOps actually an extension of secure development life cycle, and also we talked about secure design patterns as well. So those are the key points that I wanted to emphasize and highlight. So if there are any questions, now it's time for anybody. So let's talk, shall we? If you have any questions, you can raise them in our Q&A now. All right. So thank you so much for everyone for joining to this webinar series conducted by 99X. So it'd be great if you can put a like and subscribe to our channel, YouTube channel, and stay tuned, because going forward, we will have this kind of webinar series going forward in related to cybersecurity and software development, QA, and everything else. So stay up to date and turn your notifications on as well. So I'll be seeing you on another webinar series conducted by 99X. Until then, see you.